All right, welcome to The Explainer. Today, we are going to peel back the curtain on what is, honestly, one of the biggest mysteries in tech right now. I mean, you've probably played around with tools like ChatGPT or DALL-E, right? But have you ever stopped and wondered, how do they get it? How do they seem to just understand what you mean? It honestly feels a bit like magic. Well, here's the secret. It's not that the AI is actually learning English, or any human language for that matter. No. Instead, it does something way cleverer. It translates everything, every piece of data you can think of, into one single, shared language. Okay, so let's really dive into what this secret language is. And just to be clear, we're not talking about English, or even a programming language like Python. We're talking about the language of pure mathematics. See, at the very heart of any of these advanced AI systems, everything, and I mean everything, gets turned into numbers. The text you type, the images you upload, your voice, a video, heck, even stuff like DNA sequences or the chemical properties of a material, it all becomes numbers. But, and this is the crucial part, these aren't just any old numbers. We're not talking about a simple code, like A equals 1, B equals 2. No way. These are what you might call intelligent numbers. It's this really sophisticated process designed to capture the essence, the real meaning of whatever it's looking at. So the big question is, how does it pull off this intelligent conversion? Well, the answer lies in turning everything into something called a vector. And this whole process has a name. It's called embedding. And honestly, if you take one thing away from this, it's this idea. Embedding is one of the most fundamental concepts in all of modern AI. It's literally the translator that turns our complex world into a language of numbers that machines can actually work with.
So when I keep saying the AI turns things into a number, what I really mean is it turns it into a vector. And what's a vector? Just think of it as a long list of numbers, but each number in that list represents a different feature or attribute, a different dimension of meaning. So forget just X and Y on a graph. We're talking about thousands of different attributes all used to describe one single concept.
And I'm not exaggerating when I say thousands. Get this, an early version of ChatGPT used a vector with over 4,000 dimensions just to represent a single word. That's 4,096 different numbers, each one capturing some tiny, tiny nuance of what that word means. Okay, so what's the big deal? You've turned words into these giant lists of numbers, so what? Well, this is where it gets mind-blowing, because now you can do math on them. And you're not just doing math on numbers, you're doing math on meaning itself. Okay, let's walk through a classic example. Let's take the vector for the word king. Just try to imagine that the whole concept of what a king is now exists as a single point, a specific coordinate, in that crazy 4,000 dimensional space. All right, you got that point for king? Now what if we take that vector and we mathematically subtract the vector for the word man? What are we doing? We're basically telling the math to remove the idea of maleness from the concept of king. Okay, so we've taken out man. Now, let's add the vector for woman to what's left over. We've just mathematically injected the concept of femaleness into our equation. So, king minus man plus woman equals what? Well, the new vector you get from that calculation lands incredibly close in that space to the vector for the word queen. It's brilliant, right? This shows how embeddings don't just store definitions, they capture relationships. The AI didn't know that, it just calculated the answer. Okay, so this whole idea of doing math on meaning is just wild. But it brings up a good question. How does an AI even know that two vectors are close to each other in the first place? Well, it uses a nifty tool from vector math called cosine similarity. The easiest way to think about it is like a meaning meter. It doesn't really care about the distance between two vector points, but it cares a lot about the angle between them. The smaller the angle, the more similar their meaning. If they're pointing in the same direction, they're conceptually related. And this is how an AI can figure out with cold hard numbers that king is way more similar to queen than it is to, say, apple. The vectors for king and queen are pointing in a very similar direction, while the vector for apple is off in a completely different direction. And this simple idea, it's the engine behind so much of what we use. Search, recommendations, chatbots, you name it. But here's where it gets even cooler. This whole universal language of vectors, it's not just for words. This is the key to how AI can understand and connect totally different types of information. So think about it. we can take the word king and turn it into a text vector, right? But we can also take a photograph of a king, analyze all its pixels and shapes, and turn that into an image vector. So now we have two vectors representing the same concept, but from different sources. So the so-called magic behind a tool like DALL-E is a process called multimodal synchronization. It's a fancy term, but the idea is simple. You train the AI over and over again to make sure that the vector for the word king and the vector for the image of a king end up being almost identical. You force them to point to the exact same spot in this giant shared meaning space. So now, when you type a prompt like a photo of a king, the AI looks up the vector for that text. Then its job is to generate a brand new image, an image whose own vector will land in the exact same spot. It's not magic, it's translation. It's using this universal language of math as the bridge between your words and a picture. So let's just quickly break down that magic again. It's really a three-step dance. Step 1, embedding. Everything, text, images, whatever, gets turned into a high-dimensional vector. Step 2, vector math. We use math to figure out how these vectors relate to each other. And step 3, synchronization. We link different kinds of data, like text and images, by teaching them to share the same vector space. So you see, it's not some kind of dark art or black magic. It's just vector algebra. And once you grasp this one core idea, you start to see that the future of AI isn't really magical, it's mathematical. Which, of course, leaves us with a pretty deep question to chew on. If all this meaning can be translated into math, is there anything that can't be?